Okay, let's continue with another example here. Let's say we have a function here, f is m of x equals let's say 5x minus 10 over x cubed plus 4x. So as we approach this problem, we first ask the question, do we have a denominator? Yes, we do. So let's set that denominator equal to 0. Let's set that denominator equal to 0. So x cubed plus 4x equals 0. Again, we're setting that equal to 0 because it's the denominator. 5x minus 10 has nothing to do with domain here because that's neither part of a denominator nor part of a radical. So we solve this problem. So first thing I can do, pull out a common factor of an x. That gets me down to a second degree. And so then I can solve that equation. So on the one hand, x equals 0. X equals 0. On the other hand, we'd have x squared plus 4 equals 0. Now, you might be spotting right now that that's not going to work. If not, keep going, bring the 4 over. And when we apply the square root, we immediately see square root of negative 4. And we know that one's not going to give us any results that are going to apply to our problem. So that second part only gives us non-real answers. So that means there's really only one thing that makes the denominator 0, and that's x equals 0. So when it comes to the domain of the function here now, domain of m, we would say x can't be 0. But again, they're very often going to want the interval notation. So let's give it that. So not allowed to be 0, but we can be anything else. So anything over here, anything over here. And then we put that idea together. We have the interval from negative infinity up to 0, union the interval from 0 on to infinity. Okay, let's continue on with another example here. So we did a, b, c, d, e, f, g. Let's consider the function n of x equals the square root of 2 minus x plus the square root of x plus 5. Square root of 2 minus x plus the square root of x plus 5. So we go through our checklist, say, do we have any denominators? Nope, no denominators here. No denominators. But we do have radicals. They are even roots. And actually we have 2 of them. So in these more complicated ones, you may have more than one restriction that you have to deal with. Okay? Then you deal with each restriction and then put all of your information together. So here we have the radical 2 minus square root of 2 minus x. So the stuff inside that radical needs to be greater than or equal to 0. So that leads to us solving an inequality. So we bring the 2 over, get minus x greater than or equal to negative 2. And then we're going to have to divide both sides by a negative 1. And that would change the direction of the inequality. So we get that x is less than or equal to 2. So this first radical is telling me I'm only going to accept values that are less than or equal to 2. Okay, that's the limitation we must have to satisfy that piece. Then we look at the second piece, square root of x plus 5. The stuff inside that radical also needs to be greater than or equal to 0. Greater than or equal to 0. And so we would solve that inequality, right, by bringing the 5 over to the other side and get x is greater than or equal to -5. So we have two limitations here. We have two limitations that have to happen. X has to be smaller than or equal to -2, and x has to be greater than or equal to -5. X has to be greater than or equal to -5. So since it has to be both below 2 and above -5, that actually gets us into a compound inequality. It has to be both below 2 and above -5, and including those values. That gets us into this compound inequality where we have to be between -5 and 2. -5 and 2. And so here our domain of the function n would be the interval from -5 to 2.